Hello and welcome back to the OPL tutorials. This is number 5. If you've not watched the preceding 4, I would suggest you check those out first. And my apologies for this one taking so long to be made. Today we're going to have a look at time and also sound. Before we get started, I'd like to give a shout out to my 2 newest members, #FightHardMobileGaming and Zesaltdekani. Thank you very much for becoming members. Your support of the channel is very much appreciated and will help me buy the things I need to continue this channel. Now, because I've given you a shout out on the OPL tutorials and hardly anyone ever watches them, I will give you another shout out in my next video. To demonstrate the simple use of time within OPL, we're going to write a short program called age. So we're going to need a couple of local variables, age and y for year. We're going to need an input, so we're going to print year of birth, ? And that will be the input for y. So now we need to calculate age. So we could do with finding the current year, and this is shockingly simple. All we need to do is use the keyword year, and this will input the current year as a number. We can then simply minus our year of birth, and hey presto, there's our output. Of course, if you're using the Psion 2 and you've reset your calendar by 28 years because you've not added the date fix yet, then you'll need to minus 28 off your answer or you'll be out by 28 years. Once we've done that, all we need to do is print an output. So we're going to print ages, semicolon, so it prints our variable immediately after, and then age %. I've put a get so that it doesn't just close the program immediately after displaying the answer with nobody any the wiser as to what it was. So this is pretty straightforward. But of course, if we're in, let's say, August, and you haven't had your birthday yet, this is going to overcalculate your age by 1 year. So this could be easily rectified by using another OPL keyword. You've guessed it, month. So let's have a look at editing our program and adding that in. I've named it M for month. It is an integer, so it's followed by a % sign. After we've got our input for the year, I've done the same thing again. Input for the month, input equals M%. So the only thing we actually want to know is whether the month has come or gone. And when we recall a month in OPL, it gives us as a number. So for example, August is 8 and February is 2. So if the current month is, let's say, March, because that's what it currently is, and your birthday is in August, if we take the current month and minus off the month of your birth, we'll end up with a negative number. And that's all we're really interested in, whether it's positive or negative. So M% equals month minus M%. This gives us a value that is either negative, positive, or 0. And we'll come to that in a moment. First of all, if M% is less than 0, then we're going to want to deduct 1 year from our calculation. So we're going to make M% equal -1. If M% is greater than 0, that means that we've already had our birthday. And so M% will equal 0. We're going to close that if statement and then amend our calculation by adding on M%. So if you run this a few times, it works just fine, except if it's the month of your birth, because you may have had your birthday already, or your birthday might be coming up, and so it will miscalculate it by a year. I wonder how we could fix this. So you've guessed it already, we're going to use a new keyword, which is day. Pretty straightforward, and once again, day will retrieve the current day in a number format. So if it's the 23rd of the month, it will retrieve 23. So we're going to treat day slightly differently, and that's because there's no need to put the day in unless the current month is the same as the month of your birthday. This will give us an output where M equals 0. So we're going to create a new variable, d%, and then we're going to head down to those if statements, and we're going to add a new one because we currently only have if the month is greater than or if the month is less than 0. So this time we're going to put else if M% equals 0. And if that's the case, we're going to print what day. New input, and that is d%. And once again, we're only interested in whether the date has come or gone, or is the same. So we're going to do the same as we did with the month originally. So we're going to take d% equals day, which recalls the current day, minus d%, and this will either give us a negative number because the date is yet to arrive, it will give us a positive number because the date has already gone, or it will give us 0 because it's currently the same day. And of course that's reflected in our next statement. So we're going to create a new if within the current if. You can actually do this up to 8 times. So on here, I've used a couple of spaces just to make it clear that this is a new separate if, and that makes sense when you write it, but it's not necessary for the code. You can still have it all in one column. So let's follow these ifs through. So if d% is less than 0, then we know that the birthday is yet to come. So we're going to make m% minus 1, same as we did in the previous calculation. If d% is greater than 0, that means that we've already had our birthday. So we're going to make m% 0, and this will mean we'll get the correct age. And finally, else if d% equals 0, we're going to print happy birthday. We're also going to make m equals 0 because we know that that's their current age, and then we're going to close this if statement. Heading back to the main program, we don't actually need to change anything in the calculation because we've adjusted the value of m% to say the birthday has arrived or has not arrived. So as you may have already worked out, there are also OPL keywords for hours, minutes and seconds, and they're as obvious as they should be: hour, minute, second. So to have a look at those and to add a little bit of useful functionality to your Psion 2, we're going to create a countdown timer. If you are enjoying these tutorials, please do give me a thumbs up and a sub. These tutorials do not get many views as it is a bit of a niche in a niche, and they take a lot of time to produce. So your likes and subs are very important to me. So as I've said in previous videos, most of the source material for programming comes from this book. Now the programs, many of them I have either adapted or written myself. And these programs are very, very good. There is a countdown timer program in here, and while it works, honestly, I don't like it. And I'm just very quickly going to show you why I don't like it, although some of what it does is exceptionally clever. So let's have a quick look at that code. So first of all, don't be bewildered by any of it. It's quite straightforward, although it looks much more complicated than what we're going to do instead. So the first thing it does is create an input for minutes, and then we see this slightly crazy equation after it. Now what this equation does is make sure that you can never exceed 59 for the value of your minutes. So the input is m%, which is the number of minutes, and we don't want those minutes to exceed 59. So the way this works is in the brackets we get a true or false statement. So if it is correct that m is less than 60, then we get a negative number, we get -1. When we multiply -1 by -m, we get m. On the other half of the equation, if m is greater than 59, it returns a 0. So 0 times 59 is 0, and therefore we end up with the original input m%. Now, if we follow it the other way around and say that the second part is true, so that m exceeds 59, it returns a -1, which multiplied by -59 returns us 59. Now the other half of the equation will return a 0, and 0 times negative input is 0. So we end up with 59 as the result. So typing in more than 59 just results in 59, which is our maximum. If you've managed to follow that, you've done really well, but we can make an easier version, and we're going to look at that in a few moments. Moving on, as we get down the bottom, what you'll actually see, and I'm not going to go through it all in detail, but ultimately what this does is calculate the moment that the countdown timer will finish and puts it on screen as a time. Now, for me personally, I don't consider that a very good countdown timer because I'll need another timepiece to work out what the difference is in how long I've got left. So, we're going to move on from that, and instead, we're going to look at this. So this is my countdown timer program. Now I'm not saying it's better, it is different. So first of all, we're going to do the same thing and create two variables. We're going to create $M and $S for minutes and seconds. Now of course we need those inputs, and so I'm going to create a little label, and that label is min. And that's because by creating a label just there, we can jump back to it should somebody put a number in that's too high. So this is how it goes. Print number of minutes, input $M. Now we get our number of minutes, and then we check. So if the number of minutes inputted is greater than 59, we're going to go to minute. And so it'll simply loop back until you put a number in that is less than 59. By doing this, we don't need to use that complicated equation, which in my mind makes it slightly easier to follow. Now we need to close that if, clear the screen, and we're going to do exactly the same for the seconds. So again, we create this label, we're going to have an input, and we're going to check that input, and if it exceeds 59, we're going to go back to that label and start the second input again. Once the software is happy that both numbers are less than 59, we're going to clear the screen and print hit any key. After that, we've simply got a get, which will wait for the input from any key, and then we've got a new label, CD, and this is for countdown. So if the seconds are greater than 0, then we're going to make the seconds reduce by 1. We're going to pause for 20, and that is 1 second, of course, because the Psion measures time in 20ths of a second. We're going to clear the screen, and then we're going to print the number of minutes remaining and the number of seconds remaining. Once that's done, we're going to continue the loop. Once the number of seconds equals 0, we come to this statement. And actually, we're interested if the number of seconds equals 0 and there is more than 1 minute left. Because if there's not at least 1 minute left, then we need to end the program because the timer's finished. No. And then we question whether M% is greater than or equal to 1, i.e. there's 1 or more minutes left. Once that's done, of course, we need to reduce the number of minutes by 1. Now, because we've not had a pause for a second, there are actually 60 seconds still remaining. So we're going to make S equals 60 this time. And then we're going to jump back to our countdown. So that first loop will continue then until we reach 0 again, and once we reach 0 on both, we'll come out of those ifs, it'll print time up, and then we have a new command, beep, 800, 800. However, if you are on a later Psion, then you are going to want to make those numbers 16 and 800, and I'll explain why in a moment. Now we reach the end of the program. I've put a get so it pauses, and then when you're ready, click it, and we'll exit the program. So I think this is quite a nice countdown timer. It displays how much time is remaining rather than the time that everything will end at. If you wanted, of course, you could combine the two and have it print the final time and then the time remaining until that underneath. So instead of using the if loops that we created for the seconds and the minutes, we could easily have used a do until or a while and while loop. I simply used the if loops because it's one of the earliest programs that I created and I'm very familiar with it. So let's have a talk about sound. So as you've already realized, the keyword in OPL is beep, and it's followed by two numbers separated by a comma. The first number determines the length of the sound, and the second determines the tone of the sound. But it's very different on the Psion 2 to on later Psions. So that first number, the length, in the Psion 2 is defined in milliseconds, which is odd because pause is defined as a 20th of a second, so it would have made sense for the sound to do the same, but it doesn't. On the Series 3, it's defined as 1/32nd of a second. Again, not 1/20th, which you might expect, or milliseconds like they did on the Psion 2. So to have 1 second on the Psion 2, you would put 1000, or half a second is 500, and to do the same on the Series 3, 5, 7, Revo, etc., then you would need to put 32 for a full second and 16 for half a second. The differences do not stop there, although the tones are much more similar. So on the Series 2, the frequency in hertz of the sound is defined as 921,600 divided by 78 plus 2 times the tone. So for example, to get middle A, which is 440 hertz, so note would equal 460,800 over 440, which is the frequency we want, all minus 39, which gives us 1008. On the series 3 onwards, the frequency is defined as 512,000 over the tone plus 1. So for the same 440 Hz middle A, note would be the equivalent of 512,000 divided by 440 minus 1. And this gives us 1162. So they're fairly similar, but they're not quite the same. What all this means is that if you wanted to make middle A beep for 1 second, then on the series 2 it would be 1000, 1008, and on the series 3 onwards it would be 32, 1162. So what you don't want to do is when you're programming your series 3 or 5, get confused and put that you want 1000 milliseconds. You'll end up with 32 seconds of a beep. That's not going to be very pleasant. So we're just going to write a very short program just to explore these sounds a little bit more, and essentially so you can get an idea of the tones that you can produce. We're going to call it beep test, and we only need 2 variables. We need L% for length, and we need T% for tone. Now, of course, the next thing is we just need those as inputs. So we're going to print length. You might want to follow it by ms for milliseconds if you're on the Psion 2, or you might want to put 1 over 32 on the series 3 so you remember that it's a 32nd of a second. That'll then produce the input L%, and then we need the input T%. So we're going to print tone and then input T%. It's then going to produce that tone, clear the screen, print end, and then I've put a get so it doesn't immediately exit. So at this point you might want to put a menu or a loop so you can go back to the beginning. If you do put a loop, don't forget to put an exit loop on it. The other thing you might want to do is create a loop where whatever tone you've put in reduces by 100 each circuit with a short pause in, perhaps half a second, to give you a beep of reducing tone. Anyway, now you know how to make sound. Have a bit of a play. I hope you've enjoyed this video. If you have, a like and subscribe would be appreciated. We're now coming up to the final part in this series, and we're going to take everything that we've learned and put it all together to create a basic game. So don't forget to hit the notification bell so that you don't miss out on that. I am hoping to continue doing some OPL tutorials beyond episode 6, but it will depend very much on what people want. I don't get many views on these and they take quite a lot of time to make. That said, I've enjoyed it a lot, so there'll probably be the odd one now and again. As always, my name's Hugh. This is Handheld Computing. Thanks for watching.